Now, there are many different ways to divide. One of the ways that you may or may have been taught something similar is long division. And the way that you would set up long division is if you want to divide 2748, you make a symbol almost like a square root sign, but it's a little bit different, doesn't have a little tiny thing here. So it's a tiny bit different. And you would write 13 on the outside. And the way that long division worked is you went from left to right and said, are there any 13s in 2? Absolutely not. But if I go to 27, are there 13s in 27? Yes. How many? 2 of them. And you were taught in middle school that you must put the 2 above the 7. And we're going to explain that now, because usually in grade school they just tell you this is what you need to do, or middle school, but they don't tell you why. The reason that's really important is because when I put a 2 there, that 2 actually represents 200, because it's in the 100 spot. And when I do 2 times 13, your teacher would have said, just write 26. What you've actually done, since that's a 200, you've actually multiplied by 200, which was 2,600. But usually in long division, these zeros aren't written. It's just the 26. You put a subtract sign out front, and you subtract it. And 27 minus 26 is 1. And then they told you just to bring down the 4 and the 8. But really, the reason, if those zeros are there and you subtract it, you would still be left with 148. So the idea is if we multiplied 13 by 200, we'd get 2,600, which is close, but not enough. We still have 148 to go. So I switch colors. I'll go to orange. And again, you start from the left. There's no 13s in 1, but if I get to 14, there is. How many 13s are there in 14? 1. And we have to put the 1 here, which is really a 10, because it's in the tens column. And your teacher would have just said, do 1 times 13, which is 13, but it's really 10 times 13, which is 130. And we subtract again. And this will be 1. 14 minus 13 is 1. Bring down the 8, which is, if you're subtracting, would be 18. Now I'll switch colors again. I'll go to purple. Are there any 13s in 18? Yes, there's 1. And that just goes in the ones column. 1 times 13 is 13. You'd subtract and get 5. And 5 is your remaining. So what this means, and I'm going to write this in 2 different ways. What this means is that if you took 2,748 and divided it by 13, you would get 211, but you would still have an extra 5 that still needs to be divided by 13. So if you wanted an exact answer as a mixed fraction, 2,748 divided by 13 is 211 and 5/13. That's pretty accurate. Okay? The other thing that this means, and we will be writing this more often like this, is when you divide, you are trying to find out, because we're dividing by 13, we're trying to find out 13 times what is 2,748. And if we do 13 times 211, we get close, but not exact. We are off by a remainder of 5. Yes?
To get an exact value, can't you just put a 0 at 50 and then put a decimal sign at the top?
Yeah, you could, but I actually think that if you want an exact value, how much more exact can you get than that?
Yeah.
That's already your, like, 211 and 5/13. I mean, you want to get really ugly, you could change this to an improper fraction and do 13 times 211 and get 2,743. Whew. Do you know what? If you change this back to an improper fraction, do you know what you get? The same thing you started with. What's the solution to 2,748 divided by 13? It's 2,748 divided by 13 as an improper fraction. So, that is long division. Let's do the second one together. 4, 2, 1, 2 divided by 27. So you start from the left and you say, how far do I have to go before I can divide by 27? I have to go 2 digits. How many 27s are there in 42? 1. And that's really 4,200. So we're really thinking about 100. You do 1 times 27, and you subtract, leaving you with 15. Both of those numbers would come down 15, 12. Now switch colors. 1 isn't enough. There's no 27s in 15. I have to go all the way to 151. How many 27s are there in 151? Can you do 5? Can you do 6? Is 6 too many? 6 is too many, so then 5 is the most, so I put 5 here. This will be 135. I subtract, leaving me with 16. Bring down the 2. Because really, again, there's really a 0 there, there's really 2 zeros there because of what you're multiplying by. 162, this works out perfectly to be 6. And when you subtract now, you get no remainder. So this one divided out perfectly. What we're going to do is we're going to use this technique that we did in numbers in algebra. So we're now going to take algebraic statements and follow the same idea. But I don't think we have enough time to start that before the bell rings.